In this video, I will show you the FPGA implementation of a 2-bit ALU designed in Verilog. Our ALU supports 8 different operations selected using a 3-bit control signal. After verification on the Xilinx ISC project navigator, the design was implemented on the FPGA board. Inputs A, B and selection line were assigned to switches and buttons respectively, while the ALU output Y were connected to external LEDs on the breadboard through external GPIO pins on the FPGA board. Firstly, I set operation 000, which is the AND function. I set A equals to 01 and B equals to 11. On the external LEDs, the output becomes 01, which is exactly the result of 01 and 11. This confirms the AND operation is working correctly on the FPGA. Now I change the selection lines to 001 for the OR operation. With A equals to 01 and B 10, the LEDs now display 11. For the XOR operation, I set selection lines to 010 defined in the code. When A is 11 and B is 10, the LEDs shows 01. Now I select 011 for the NOT operation. A is set to 01 and the output LEDs display 10. This is the bitwise NOT of 01, so the NOT operation is also working properly. For addition, I change selection line to 100 with A is equals to 11 and B is equals to 01. The ALU perform 3 plus 1 and the LEDs show 100. This is the correct binary result for the decimal value of 4. Next, with selection of 101, the ALU performs subtraction. A is 10 and B is 11. This gives the result -1, which is 3-bit 2's complement of 111. The LEDs show 111 exactly as expected. For the increment operation, selection is set to 110. When A is equals to 01, the output LEDs shows 010, which is the value 2. So the ALU is correctly incrementing the value of A. Finally, I set selection to 111 for the decrement operation. With A equals to 00, the result becomes -1 represented in 2's complement as 111. The LEDs confirm this by displaying 111. By testing each operation one by one on the FPGA and observing the result through the external LEDs, we verified that the 2-bit ALU is functioning exactly as designed both logically and arithmetically.